Good morning, all of you. So, in the last class, we have learned heat engine. In today's class, we will learn exactly opposite of that. That is what refrigerator. What is that? Refrigerator. So, see, I will draw first a block diagram, same like heat engine. Same diagram like a heat engine. Just direction is going to be reverse. Keep it in mind. Same like heat engine, nothing change. But what is the difference? You will get to know very soon. I think now you understood what is the change. In the heat engine, arrow was from top to bottom, but here now bottom to top. Work was done, but here work is done on the system, right? Like this situation is there here. So see the parts. This is source, and amount of heat given is Q1. Its temperature is T1. Here this is W, and W is equal to Q1 minus Q2. This is sink as usual at temperature T2, and Q2 amount of heat is given or taken from the sink. This is what your refrigerator diagram. So let's see ahead now. What are the differences basically you are getting in a refrigerator? So have you seen in everyone's house there is a refrigerator, but see, keep it in mind, outside it is hot but inside it is cool. Yes or no? Even in summer also you are getting ice, isn't it, right? So it is doing some reverse process. Got it? So what it is doing, let's see. First of all, definition of this refrigerator. A refrigerator is basically a heat engine run in reverse direction. Run in reverse direction. You see, in a heat engine, the direction was reverse like this, but here it is reverse directions. Okay. So refrigerator is basically a heat engine run in a reverse direction. Next one, it consists of three parts. It consists of three parts. Same like heat engine, okay, nothing changed. But how the operation is changing, let's see. The number one is as usual source. So you know source is what? It is at high temperature. It is a hot reservoir. Any amount of it can be extracted from it. But here I am writing in a short, that is what? At higher temperature T1. Source is at higher temperature T1. In this refrigerator we want this only. At higher temperature T1. Second one, working substance. So in heat engine we have learned what is the working substance. In diesel engine, fuel and air mixture, है ना? Steam engine, steam. But here in refrigerator, what is working substance? Refrigerant liquid ammonia. Refrigerant liquid ammonia and Freon works. Freon works as a working substance. In this refrigerator, refrigerant liquid ammonia and Freon. Freon means what? Outside part है ना, जो frame रहता है ना वैसे. Freon works as a working substance. Next one, third one. What is the part of sink here? Which is very, very important. What is the part of sink? So basically in everywhere sink is at very low temperature T2. So shall I write at low temperature T2? Sink is at lower temperature T2. The heat or the working substance takes heat Q2. Next line. The working substance take heat Q2 takes heat Q2 from a sink at lower temperature. Now you should ask me a question, sir. How it is possible? First of all, how heat is transferring from lower temperature to higher temperature? Actually, it is not like that. So what it is doing? See, the working substance, whatever this refrigerant, liquid ammonia, and freon is there, they are taking heat from Q2, which is at lower temperature, but they will work on it and they will increase the temperature more than the source, and then they will give the heat to the source. Understand? Keep it in mind. That is what the beauty of this refrigerator. Otherwise, heat will not absorb. If suppose one cool body is going to give heat to the hot one, that is not possible. So what we are doing, taking heat from sink, processing on it or working on it, increasing temperature more than source, and then it is possible we can give the heat to the source. Like that process is happening in this refrigerator. Got it? So see now, so sink is at lower temperature T2. The working substance takes heat Q2 from sink at lower temperature, has a net amount of work done W on it, has a net amount of work done, has a net amount of work done W on it by an external agent and gives out a larger amount of heat and gives out larger amount of heat Q1 to a hot body at temperature T1. Thus, it transfers heat from cold body to hot. But how? By processing or by doing external work, है ना? Thus, it transfers heat from a cold to a hot body at the expense of mechanical energy supplied to it by an external agent. Okay, this is very important line. Keep it in mind. Thus, it transfers heat from cold to a hot body at the expense of mechanical energy supplied to it. Mechanical energy supplied to it by an external agent. And therefore, or thus, cooled body or the cold body, we can say. This cold body cools more and more. Cools more and more. Okay. Now, in the heat engine, we have learned coefficient of performance. Coefficient of performance was what? Work done divided by heat supplied. Now here in this refrigerator, you are having coefficient of performance. Coefficient of performance. And it is denoted by beta. That was denoted by alpha. This is denoted by beta. Okay. This one coefficient of performance is denoted by beta. Okay. Let's move ahead now. It is the ratio of heat extracted from the cold body to the work needed to transfer it to the hot body. Very simple definition. See here. It is the ratio. It is the ratio of heat extracted from the cold body. Heat extracted from cold body. Heat extracted from cold body to the work needed to transfer it to the hot body. Okay. It is the ratio of heat extracted from cold body to the work needed to transfer it to the hot body. So we know, see here, therefore beta is equal to heat extracted is what here? Q2 divided by W. And therefore beta is equal to Q2 divided by Q1 minus Q2. This is also equal to T2 divided by T1 minus T2. This is what your beta formula in case of refrigerator, and it is also, what is its name? Coefficient of performance. Keep it in mind. What is the beta means? Coefficient of performance. Understood? So read it once carefully. The difference between heat engine and refrigerator you will understand. Okay. Right? So let's solve one problem on this also. Okay. So note down this and let's solve one problem. A refrigerator is to maintain a refrigerator is to maintain eatables kept inside at 9 degrees Celsius kept inside at 9 degrees Celsius. If room temperature is 36 degrees Celsius, if room temperature is 36 degrees Celsius, calculate the coefficient of performance. Even you can check your fridge temperature or whatever you have kept inside the fridge, okay, and outside temperature, and you can find out coefficient of performance of your fridge. And at home also you can do that if you have thermometer. I think digital thermometers are there, so check it. If it is possible, you can tell me the coefficient of performance of your fridge which is at home. Calculate the coefficient of performance. Calculate the coefficient of performance. Okay, this is what question they have asked. Very simple question actually on this model. Now, what is given here? Given is sink temperature and source temperature, right? So source T1 is equal to 36 degrees Celsius. So shall I convert it into Kelvin? So 36 plus 273, that is equal to 309 Kelvin, 309 Kelvin. Okay. Next one is T2, that is sink. Sink temperature T2 is 9 degrees Celsius. If I will convert it into Kelvin, then 9 plus 273, this is equal to how much? 282, right? 282 Kelvin. Check it. Now, beta he is asking. Beta is equal to question mark. So very simple. This is beta is equal to, what is formula? T2 divided by T1 minus T2. What is T2 value? 282 divided by 309 minus 282. So beta is equal to, this is how much? 8 and 18 plus 9, 27, right? So this is 282 divided by 27, and therefore in this problem you are getting beta, that is coefficient of refrigerator or coefficient of performance is 10.4 after solving this. Check it. Check it once. Check it once. Yes, 10.44 is coming. Okay, understood. Very simple problems are there on this model. One more problem we will solve, which is based on this steam engine. Okay, so based on steam engine, this is not on this refrigerator, but we will solve. A steam engine delivers a steam engine very simple problems are there. You just go through this. Steam engine delivers 5.4 into 10 to the power 8 joule of work per minute and services 3.6 into 10 to the power 9 joule of heat per minute from its boiler. From its boiler. Boiler, have you seen? Boiler means what? You know, some companies, I think you might have seen. जहाँ पे हीट जनरेट होता है ना, जनरेट करते हैं लकड़ी डाल के, और इवन समटाइम्स by using electricity also. It's boiler. What is the efficiency of the engine? What is the efficiency of engine? How much heat is wasted per minute? First you have to find efficiency, and next how much heat is wasted per minute. How much heat is wasted per minute? Okay, this is what the question is. Let's solve it now. So here you see this one, they have given work per minute, है ना, here, and this is also per minute only. Okay, so first let me see what is given here. So steam engine delivers this work per minute and services this heat per minute. Okay, so see, work done is how much? Less, and heat supplied more, right? You see here, this is 10 power 9, this is 10 power 8. So this is more and this is less. So heat absorbed per minute, I am writing first. Heat absorbed, and that is also per minute. Okay, heat absorbed per minute is equal to how much? 3.6 into 10 to the power 9 joule. And work done per minute, that is also, so work done per minute, how much they have given? This much, right? Okay, so 5.4 into 10 to the power 8 joule. This is what your work done per minute. Now you have to find efficiency. This is per minute only, no? So not an issue. So efficiency eta is equal to work by heat. This is per minute or this is per minute. Both will get cancelled, or even you can keep like this also. So how much? This is 3.6 into 10 to the power 9 divided by 5.4 into 10 to the power 8. So if we will divide this, how much you are getting? Check it. This is 18 means 0.2, right? And this is 0.3, right? Check karo. Work done is what here? Wait. Ulta ho gaya, right? Work done is reverse, we have written. Not this. Okay. This is work done, no? So 5.4 into 10 to the power 8 is the work done, right? Divided by heat is what here? 3.6 into 10 to the power 9. So if we will solve this, we will get 0.15. But we will get 0.15. And therefore percentage efficiency is equal to 15%. This is what efficiency. Next one is heat wasted. He is asking heat wasted. How much heat is wasted per minute? He is also, that is also per minute only. So heat wasted per minute, heat wasted per minute, everything is per minute only. So I'm writing here. So heat wasted is equal to what? Supplied minus work, right? Or absorbed minus work. Heat absorbed minus work. This is ABS means absorbed. So heat absorbed is how much here? 3.6 है ना? Check करो. 3.6 into 10 to the power 9 minus 5.4 into 10 to the power 8. So this is how much you are getting. If you will subtract this, you are getting 3.06 into 10 to the power 9 joule. This is what heat wasted in this problem. That is also per minute. Okay, check karo. Check it, everything is right. Check this calculation. Work done per minute is 5.4 into 10 to the power 8, right? Only no. And heat absorbed per minute is 3.6 into 10 to the power 9. So 5.4 divided by 3.6 is equal to 1.5 into 10 to the power minus 1, right? Only 0.15. And percentage means just multiply by 100. Therefore, percentage efficiency is 15%. And heat wasted is equal to heat absorbed minus work done per minute. Everything is per minute only. And just heat absorbed minus work you have subtracted. So just check it. That is 10 power 8. Okay. So if you will take here 0.36 or just 360, 360 into 10 to the power 8 this side. Understood? So many of you might have confusion here. Let me do this in the box. This one you see, this subtraction, can I write like this? 360 into 10 to the power 8 minus 5.4 into 10 to the power 8. So this is equal to 360 minus 5.4 into 10 to the power 8. Okay. So how much you are getting? This is 306 है ना? 306 into 10 to the power 8 है ना? Here 36 should come. No? How much you are getting? Here shall I take 7? 1 minute, 1 minute. Here I should take 7, right? And here I will make 54 into 10 to the power 7. Okay. 1 minute. This subtraction I am doing. See. Can I write like this? This is 360 because I have shifted 2 decimals, so not 8, but you will get 7, right? 10 to the power 7 minus this also again I am replacing here. So this is 54 into 10 to the power 7, and then I am taking this 360 minus 54 into this 10 to the power 7. Right, so how much you are getting now? Check it. 306 into 10 to the power 7, and then after that 3.06 into 10 to the power 2 into 10 to the power 7, you will get this. Is that clear now? Check it. Check it just for understanding. JFU. Check करो. फिर से करो. So that you will understand this point. Okay, 3.6 here. This is 5.4. Okay. Check करो. Check करो. Is that clear now? Any doubt? So you are getting this as a 3.06 into 10 to the power 9 joule. Okay. So we'll stop here for today. I'm sending you assignment. Please solve that. Don't forget.